Morning, everybody. I want to start with a short demonstration today. See if you can see this. So I have a propane tank and I have some soapy water in here. I'm going to bubble some propane into here. We'll do that really fast. Now, if we were all at school, you could all do this, but fortunately, we're not. So whenever you come back to school, you can get a chance to do this. But in the meantime, I'm going to show this to you. So these bubbles are full of propane. I'm going to go ahead and, this is important, pull back my sleeve, put some water on my hand, and then I'm going to get a match lit away from the propane bubbles. I'm going to hold some bubbles in my hand. Okay, so you can see my hand lit on fire. You can see that the bowl lit on fire. Wasn't expecting the bowl lit on fire, but that's okay. It's perfectly safe. My hand actually still is wet. So I add some water to protect my hand in case anything, the fire stays on for a while. You can have the water evaporate. It won't hurt my skin. But it's safe because the amount of propane on my hand was so little, the flame went out very fast. Same thing with this bowl right here. It lit on fire, but the flame only lasted for a second because the amount of propane it had in the tank was so small. Once that goes out, there's no flames. So when we come back to school, I'll have you all get a chance to do that. It's very safe. I know it looks like it's dangerous, but it's a very safe experiment. You'll get a chance to light your hands on fire. But anytime I want to show that to you. Let's see, Lauren had something in the chat. I can't read it though. Well, I'll get to that later. Let me go ahead and clean this up, and then I'm gonna do a few notes on the whiteboard. Get the whiteboard pulled up. Oh, Lauren said we have to just get back. Yes, whenever you come back to school, you'll get to do this. Like, that'll be the first thing we'll do when we come back to school. And it's really cool because you can feel the heat of the flame on your skin, but it doesn't burn you. Okay, so we're on 12.2 today. Let me go through a short example with you all. So in this equation right here, we're looking at potassium, which is K, reacting with water to produce potassium hydroxide. Actually, that should be a 2 right there too. And H2 gas. So we have 2K reacting with 2H2O to produce 2KOH plus H2. Let's say that we have 0.4 moles of potassium reacting. So that's just given to us. We're just told in this reaction that we have 0.4 moles of potassium. And the question might be, how many moles of KOH would be produced? So we're given moles of potassium. We want to know how many moles of KOH should be produced. We would look at the ratio between those two chemicals. So our molar ratio would involve potassium and KOH. So we could have two possibilities. We would have 2 moles of K over 2 moles of H2O. Or we could have it flipped, where we'd have 2 moles H2O over 2 moles of K. Which one do we use? Well, we're given this right here, 0.4 moles of K. So let's write that out here again. And we want to cancel out K. So we'd multiply it. Sorry, my text, I can't turn that off, so hopefully it won't go on for too long. The K right here would cancel out. So we'd have to use this one right here because that would ensure we cancel out K. So we would have to choose which one cancels out thing that what we want. In this case, we want to cancel out that. Oh, I'm sorry, I misread that. That should not be H2O. We're going to look at KOH. It's the same ratio. I just was reading the wrong one. So that should be KOH there. That's what we wanted to find out, not H2O. Okay, so that will cancel out the one that we have, which is K, and give us KOH, which we want to find. So it's 0.4 times 2 over 2, which reduces to 1 over 1. So basically, we're multiplying it by 1. So you would get 0.4 moles of KOH. So if we have 0.4 moles of K, we will also get 0.4 moles of KOH produced in the reaction. What about H2? So again, we have to use what we've been given. We've been given 0.4 moles of K, and we'll multiply it by the ratio of what we have, which is K, and what we need. And so if we want H2, that would go in the numerator. It's 1 mole of H2. So if there's no number in front, we just read that as 1. So 1 mole of H2 over 2 moles of K. K will cancel out. H2 remains. So it's 0.4 times 1 over 2. We get 0.2 moles of H2. And that is for anything in this reaction, whether it's products or reactants. We can use the ratios to relate any two chemicals, no matter what side they're on, the same side, different sides, it doesn't matter. Any questions about that? Okay, so that's it for the lesson today. On page 375, do questions 11 and 12 for today. So questions 11 and 12 on page 375. Oh, Lauren, I saw you had your hand raised. Did you have a question?
Yeah. How did you know which one to pick, potassium over H2O or H2O over potassium?
Oh, that's a good question. Let me go back to that really fast. So I couldn't see, on my screen, I only see like 4 people at a time, so I didn't see you had your hand raised. So for that one, I'll just rewrite it again. It'll be easier that way. So we had 2K plus 2H2O goes to 2KOH plus H2. And we were given 0.2 moles of K. And we were asked to find KOH. So we would relate what we have, which in this case we're given K, to what we need, which is KOH. And so again, we have 2 possibilities. We could have 2 moles of K over 2 moles of KOH, or vice versa. KOH over K. Which one do we pick? Well, we want to pick the one that will cancel out what we already have. So what we have is 2 moles of K. If we were to use this one right here, we'd multiply this, it'd be K times K. We wouldn't have anything cancel out here. So this one would be the wrong one to choose because multiplying this by this, the units don't cancel out. But if we choose the other one, then what happens? We multiply it by 2 moles of KOH over 2 moles of K. Now the K will cancel out, which is what we want, and we'll be left with the unit that we need. We want KOH. We were asked to find out the moles of KOH. So this way, we would get moles of KOH for our answer and cancel out moles of K. And so we get 0.2 moles of KOH. Does that make sense?
Yes, thank you.
You're welcome.